All right, today it is our goal to formalize the algorithm for a triangle. And yesterday, you guys worked really hard, and Cooper gave us an amazing summary of the strategies that we use to find the area of a right triangle. And remember, that's a triangle that has a 90-degree angle. We found a formula for an isosceles triangle, and that was a triangle where two of the sides were the same length. And we left off yesterday talking about a scalene triangle. And that's a triangle that has sides that are 3 different lengths. And so that's what we're going to pick up today. Now, what was the formula that we figured out that should work for triangles? What was that formula or that process that we can use that will help us to find the area of a triangle? Joey, what was it?
Base times height divided by a half.
Not quite. Divided by 2. So I'm going to write area equals base times height divided by 2. Okay? And really quickly tell the person next to you how that formula works to find the area of a triangle. Okay, so explain to us how we came up with that formula yesterday.
So what you would do is you would draw a box around the triangle, and then if it's a right triangle, then the triangle should be going from one corner of the box to the other corner, which makes it 1/2 of that box. So what you do is you do the base times the height divided by 2 because the triangle is half of that box. And if you have an isosceles triangle, then you draw a box around it, and then if you go from the height and you draw a straight line down, then you come up with 2 right triangles, which means that the triangle is half of that box.
Great, that is awesome. Thanks for sharing, Samantha. So the big idea is that our base and our height will give us the area of a whole rectangle, and then we can divide it by 2. So we talked a lot yesterday about finding the area in relation to a rectangle. And today we're going to talk about finding the area in relation to a parallelogram. So I just have another example up here to show you. And this says, study the figure below to visualize one way to understand triangle area. And it says the area equals the base times the height divided by 2. And on Monday, we talked about that the area of a parallelogram is base times height, right? Okay. So I'm going to take this triangle right here, and I'm just going to turn it into a parallelogram. So I'm just going to take this part right here, the exact same area for the triangle, and then just rotate it and double so I can get a parallelogram. So can you see how this triangle here is half of the area of a parallelogram? And if we know that the area of a parallelogram is base times height, then our triangle is just going to be half of that. Okay? So that's just another way for you to think about it, in addition to what you did yesterday. And then, as a reminder, the perimeter of any figure is the sum of all the side lengths. Okay? So our perimeter, P, equals side plus base. And we are working really hard on making sure that we have equations. Okay, so if you want to make a little note to yourself that that's an equation, that would be a great idea. Okay, I'm going to move down here. And here's one of those scalene triangles that we looked at yesterday, but we weren't quite sure if this formula is also going to work on a scalene triangle. All right? So what I would like you guys to do is take a little bit of time, and I want you to first use the grid to find the area without using an algorithm. So use your grid to see if you can find the area of that triangle. I want to show you guys a strategy. I saw a lot of you trying to break this up different ways in order to find the area. I want to show you guys another cool way to do this. And if you can do this, this is going to be really helpful when you're in 8th grade. We do something very similar to this. So the first thing that I'm going to do is I'm going to find the area of this whole entire box here. Okay. And I know that this box is 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So the area of the whole entire box there, the whole rectangle, 6 times 9 is 54, okay? Units squared. Now the next thing I'm going to do is I'm going to subtract out parts of it that aren't there. So I'm going to start by finding the area of this triangle right here. Okay? And the triangle right there is 5 by 6. It has a base of 5 and a height of 6. Okay? So I know 5 times 6 is 30. And then if I divide that in half, the area of this part that I outlined in red, this triangle, is going to be 15 units squared. Okay? So I just did the base times the height, 5 times 6, and then I divided that by 2. All right. Now I'm going to do the same thing with the larger triangle up here. With this one right here. And this triangle right here, this length right here in green, is 9 times 6, which is 54. Okay, and then I'm going to divide by 2, so this will be 27. And if I want to find the area of the shaded figure, I'm going to start off by giving the area of the whole rectangle, which is 54. And then from that 54, I'm going to subtract 27. And then I am going to subtract 15. Okay, so I started off with the whole area there, and I'm going to subtract out those 2 parts. All right, so 54 minus 27 is 27. And then 27 minus 15 is going to give us 12 units squared. Yeah. Totally could. And that would look like this. So we could write it as well as 54 minus 27 plus 15. We could do that as well. That would work. Okay, so that's one way that we can solve it. Let's talk about a second way. Yeah. Okay. All right, so I'm just going to erase all this that I've drawn on here so we can start fresh. So let's start by talking about the base of this shape. Okay, now as I was walking around yesterday, I noticed that some of you were giving the entire distance of this your base. The part that I just highlighted in black, that's your base. So it's 1, 2, 3, 4. We have a base of 4. Okay? So if you wrote down 9, that would be incorrect. It's just the part that it rests on. Now our height, imagine that we're just going to take a little walk up to the very highest point on our triangle, and then we drop a rock here, and that's going to be our height. So this distance right here is our height. And our height in this case would be, what do you guys get for your height? 6. All right. All right. Isaac, will you help me use the algorithm to find the area of this triangle?
Sure.
Okay.
So A equals 54.
So we have base times height
Yeah. Oh, yeah, sorry. So
divided by 2. Okay, help me fill that in.
base is 6.
Okay, so A equals
6 6 times,
What's our base?
5 times 6,
What's our base?
4, sorry,
Okay. Times.
times 6,
Okay.
divided by 2.
Okay, keep going.
4 times 6 is 24,
So A equals 24.
and 24 divided by 2 is 12.
Yeah, so we still have 12 units squared if we use an algorithm too. So that formula that we came up with yesterday is going to work for any triangle, which is pretty awesome. The next thing I would like you guys to do is I want you to start tackling problem 1 and problem 2 and problem 3. And then we'll share our ideas. All right, Tatum, what would be our formula for the perimeter of number 1? We're doing perimeter. Okay.
I just did that today.
Okay.
So I did the formula. Then I did I added all the sides together, which were 2.5 times 2.
So do you see there's only 2.5 here? And then we are going to add this side, and then we'll add this side. Okay? So 2.5 plus.
2.5 plus 6. And then plus 6.5.
Awesome. And what would we get when we add all of those together?
15.
Yeah. So for our perimeter, we should have 15 centimeters. All right. Let's do area. Louis, you're going to help me with area?
I think I just realized something.
What'd you just realize?
For the isosceles triangles, can you just like flip it and then do the box and then do the way you're doing it? Because if you like flip it, then it's
Like the isosceles, like, we don't have an isosceles triangle up here.
or like the ones that are oblong or whatever it's called.
Scalene?
Scaling, yeah.
What do you mean just flip it? Like
Flip it so the obvious part is on the bottom.
like this?
Yeah. And then
Good afternoon, Louis. Fill in the middle. All right, so for number 1, if we're going to do the area of this, okay, we're going to say base times height divided by 2. So we have a base of 6 times a height of 2.5, and then we'll divide that by 2. So 6 times 2.5 is 15, and then divided by 2, we would have an area of 7.5. For that one. All right, you should be taking these notes with me, please. All right, for number 2, our perimeter for this one is going to be 4.2 plus 9.5 plus 6. Now we have to be really careful that we do not add the height. The height is not part of the perimeter. So if we add all of these together, we'll get 19.7 for our perimeter. Now for our area for this one, we're going to use the same formula we've been using. So we're going to say 9.5 times 3 divided by 2. All right. So our area, 9.5 times 3 is 28.5. And then we'll divide that by 2. Right, exactly, which is 14.25. So our area is 14.25 centimeters squared. Now our last one here, we have been told that the perimeter is 168. So we're going to add up all three sides here. Okay? But we don't know this length right here. So I'm going to say 168 minus these two sides that I have. So minus 91. And I'm left with 77. So I know that the length of this missing side here is 77. Yeah.
Where'd you get the 91 from?
Good question. That's 51 plus 40.
Okay.
All right, now we're going to do exactly what Louie was talking about earlier. We're going to take this shape and we're going to think about rotating it. And looking at this, we know that this length along the bottom is 77. And we know that the height right here is 24. Okay? And then we're going to use the same exact thing we've been doing the whole time, the same exact formula. Our area is our base, which is 77, times our height, which is 24, and then multiply that by 2. So I'm going to do some scratch work over to the side so that my equations stay really neat. And 77 times 24, 4 times 7 is 28. 4 times 7 is 28 plus 2 is 30. 2 times 7 is 14. 2 times 7 is 14 plus 1 is 15. So I have the area is 1,848 divided by 2. And when I think of this, I'm going to find half of, write this down please, half of 1,800 and then half of 48. So I would have 924